Level 2, Number 1. Jim is running on a trail that is 5/4 of a mile long. So far, he has run 2/3 of the trail. How many miles has he run so far? This is a subtraction problem because that means he's already run this much and we want to know what's left. So what we're going to do is we're going to take 5/4 and we're going to subtract 2/3. Well, when we are subtracting fractions, we need to make sure there's a common denominator. So we're going to find a least common multiple for 4 and 3, which would represent it as 12. 4 times 3 is 12, so that means 5 times 3 is 15, and that's what goes here. 3 times 4 is 12, so 2 times 4 is 8. Now we can subtract because we have a common denominator. So 15 minus 8 is 7/12. We cannot simplify this any more than it already is, so this is our answer for number 1. Number 2. It says solve the equation. 15 equals 7 minus x. So we have a line down the equal sign, and we know we have to remember we're doing PEMDAS backwards. So addition and subtraction has to be taken care of first. So we look here and we know that the 7 is our addition and subtraction, so we're going to have to subtract 7 on both sides. Right here, since there is no negative present, it's known just not shown, that's a positive 7. Therefore, the inverse operation is negative 7. So 15 minus 7 is 8 equals negative x. So I'm bringing down whatever's left. Now I see that there's a negative x, and it's known just not shown again that there is a negative 1 existing, so we have to do the inverse operation, which represents dividing by negative 1. So those go away. We're left with x on the right hand side. X equals 8 divided by negative 1 is negative 8. Number 3. It says solve the inequality. So 4 minus 10x is greater than negative 21. So a line down the inequality, we're going to subtract 4, which is PEMDAS backwards, so we're taking care of the addition and subtraction first. So this goes away. I'm going to bring down my negative 10x. It's greater than negative 21 minus 4 is negative 25. Therefore, the only thing left is the negative 10 times x. Therefore, to get rid of that, I'm doing the inverse operation, which is dividing by negative 10. So x is the only thing left on this side. And remember, I just divided by a negative, therefore my inequality is going to switch. And I'm going to divide over here, negative 25 divided by negative 10. I can simplify that. It's going to be a positive answer, which would be 2 1/2. Number 4. Simplifying the following expression. So I have 6x plus 3x minus 9x plus 5 plus negative 9. So this is when, if you have extra colors in hand, that's always helpful. Or you can make shapes or box it up, chop it up method, however works best for you. So I love the color method, so I'm going to do that one. So I have x's, so I'm going to make a blue circle around all my x's. And then I have a purple, so I'm going to make a purple circle around my constants. Okay. Now remember our train, so exponents, if they are there, exponents are our engines, so those go first, and our constants are our caboose, so those would go last. So our x's would need to go first, since the constants go last. So I have 6x and 3x, that's 9x. 9x minus 9x is 0x. And then there are no other x's present, so our answer for that would be 0x. Okay, now our constants, which are our purple circles, so it's plus 5 minus 9, that would give us negative 4. So we're going to simplify this even further. This is a 0, so if you want to put a line next in between it, that's fine to recognize that's a 0. 0 times x is just 0, so the only thing left in this expression is negative 4. Number 5. It says graph the inequality on a number line. Negative 6 is greater than m. So on a number line, it would look like this. So negative 6. And m is less than negative 6. So it's an open circle because it cannot include -6. And if it's less than, then it means it's going to the left. Less than is to the left. Number 6 says solve this inequality. So 18 is less than 4m minus 15. Line down the inequality. So we're doing PEMDAS backwards just like before. So we're going to have to add 15 first. Oops. So 8 plus 5 is 13. Carry the 1. 1, 2, 3. Bring down whatever's left on the other side. Now we're going to divide by 4. And we see it's not going to be a very pretty fraction, but that's okay. We can see, okay, how many times can 4 go into 33? Be 8 times, which would mean, because 8 times 4 is 32, so that means there's 1 left, and 4 is a fraction. Okay, so number 7. Alright, here we go. Number 7 says the proportion of red marbles to blue marbles in a jar is 2 to 5. If there are 35 blue marbles in the jar, how many red marbles are there? This is a great example of a question we set up a proportion for. So we have 2 out of 5 are blue. So if we want to know if there are 35 blue marbles in the jar, how many red marbles are there? So we're assuming that if they're not blue marbles, they are red marbles. Then our proportion right here is already set up for 2 would be blue out of the total. So if we're looking for the red, we need to find what's left. So if there's 2 blue, then that means there'd be 3 red. So 3 red marbles out of the total. Total of 5. Okay. So then we can set up our other side of the proportion by representing the red marbles
redo on number 7. We can't come out of it.
That's okay.
Oh, we could have freeze framed it, I bet. Or no.
Can I do that?
See what happens when you press record on it.